Hi guys, welcome back to In Case of Econ Struggles. Welcome to another micro struggle. Today I'll be talking about expected value and properties of expectations. Expectations come up a lot in economics, both in micro, macro, and metric, so I just want to talk about a couple properties of expectations, including the law of iterated expectations and conditional expectations. Timestamps are below if you would like to jump around, but let's get right into it. So here is just a brief motivating example of an expected value problem. So maybe Bill is flipping a coin, and if it lands heads, he gets $10, and if he gets tails, he gets $0. And we're trying to ask what is the expected value of this gamble or this coin flip. The answer is $5. How did I get to $5? Well, there's a 50% chance that Bill gets heads and gets $10. There's a 50% chance that the coin lands tails and he gets $0. So I add those two up and I get $5 total. If I wanted to make this more general, if it wasn't just two possibilities, if there were maybe like n possibilities, then what I could do is I could just take the probability, or P, the probability of each event happening, times how much money I get if that event happens, add them all up. And this is a long sum, so I can just represent that as this sum here from 1 to n of Pi times Xi. Just as a brief example, maybe I'm doing a gamble with three possibilities. Maybe there's a 25% chance that I get $20, a 50% chance that I get $10, and a 25% chance that I get $0. And I'm asking, what is the expected value of this gamble? Well, just like with the coin example, I'm just going to add up the probability of each event times the payoff of each event. So the first event has a probability of 25%, gives me $20. Second event has a 50% probability, and I get $10. And the last event has a 25% probability, and I would get $0. So this is $4, this is $5, this is $0. So the expected value of this gamble is $9. Notice that expected value is not the same as expected utility. I talk about that difference in a separate video. Feel free to check that out if you are interested, but we're just talking about specifically expected value here in this video. Let's talk about some properties of expectations more broadly. The first is that they're additive. So if I have two events, so two coin flips, X and Y, and I want to know the expected value of doing both of them, I can just add up the expected value of X and the expected value of Y. If there's a scalar, so if I multiply all those payoffs within that coin flip by 2, I can just take the 2 out and do 2 times the expected value of the original coin flip. So for example, if I wanted to flip a coin 3 times and do the expected value of flipping a coin 3 times, I could just do 3 times the expected value of flipping a coin once. And unsurprisingly, the expected value of a constant is a constant. So for example, if I have a bunch of people and all of their height is 5, and I ask what is the expected value of everyone whose height is 5, you're going to tell me, congrats, the height is 5. Why? Because the average of 5 is 5. Remember, when we're doing expectations, we're thinking average. So the average payoff, the average value is what we mean when we talk about expected value. So if I ask the average value of 5, that's just 5. Now we'll talk about the law of iterated expectations in a second here, but first, what it is, this is just my expected value of X is just my expected value of X. Another way you could think about expected value is just best guess. So if you had to make a best guess about what the value of this coin flip is, then you might just say, well, it's a 50% shot of getting heads and a 50% chance of getting tails. So my best guess is just the average between the payoff if you get heads and the payoff if you get tails. So that's like a best guess. Another way to think about the law of iterated expectations is the average of an average is just a simple average. There's no need for that second average. Where that comes in handy is when you start dealing with time. So for example, if I want to make my best guess as to the weather on Wednesday, well, on Tuesday, I'm going to use this little t, and I'm just going to say, well, that's my guess on Tuesday of the weather on Wednesday, where X is the weather on Wednesday. But what if on Monday I said, what is your best guess on Monday of X? And you would say, well, it's just my best guess of X today, given everything that I know on Monday. What if I asked you, all right, what is your best guess today on Monday about your best guess tomorrow, Tuesday, of your best guess of Wednesday's weather? Well, then you would just say that my expected guess of Monday of Tuesday's guess is just Monday's guess. There's no reason that your best guess about your best guess tomorrow should be any different than your best guess today. So that's the way I think of law of iterated expectations. My guess about my guess tomorrow about something later down the line is no different than if you just asked me what is your best guess today of that future event, and you just didn't bother to ask me about my best guess about my guess. You just asked me what is your actual guess today about what's going to happen in the future. So that's the law of iterated expectations. Something that is not a property of expected value or expectations is it's not the case that multiplying x times y, the average of my best guess of x times y is equal to my best guess of x times my best guess of y, because it's actually the best guess of x times the best guess of y plus the covariance between x and y. This is what we use to find correlation. What does that mean? Well, if the average of x times y is greater than the average of x times the average of y, you have positive correlation, because that would mean that this covariance is positive. If it's reversed, this covariance is negative and you have negative correlation. And if it's exactly equal, that would mean that this covariance is 0, and so you have a 0 correlation between x and y. We also have this thing called conditional expectations, so I'm going to talk about what that means. So I've got two people. I've got Bill. He's 1 inch tall because he's an iPad drawing. And then there's me. I'm 5'9". I am not an iPad drawing. So our expected height, our average height between the two of us is 2 feet 5 inches. But if I condition on whether or not you're an iPad drawing, so I just take the height of people who are an iPad drawing, then that average is 1 inch because there's only one person. Only Bill is an iPad drawing. The way we would translate that in English is to say that the average height among iPad drawings is 1 inch, and the average height among non-iPad drawings, or my height, is 5 foot 9 inches. Hopefully this just gives you a real brief overview of expectations and some of the properties of expected value, as well as the law of iterated expectations. If this was helpful, make sure to like and subscribe, and we will see you next time for another case of Econ Struggles.